Alcohols are weak electrophiles. They can, however, become strong electrophiles when they are in the presence of an acid. In this example, an alcohol, in adding hydrobromic acid, protonates the alcohol, and then the bromine ion undergoes an SN2 reaction, replacing the water leaving group. The problem with alcohols acting like electrophiles in this type of reaction is that it requires an acidic environment, and the trouble stems from the fact that most strong nucleophiles are also strong bases. So in reactions of this type of environment, most of the time these things will act like bases before they act like nucleophiles. And this second example is a display of that. So here we have that protonated alcohol from a strong acid. Here is a nucleophile, but we don't observe an SN2 reaction. Instead, what is observed is the nucleophile acting not like a nucleophile, but a base. And this is a problem. The only things that will be able to work in this mechanism where we use acid are nucleophiles that are not strong bases, and there aren't very many of them. The most common example of this would be a halide. Halide, they are the conjugate bases of strong acids, so they're extremely weak bases. And this is going to be one of the very few situations where we're going to be using something like this, because this will not act like a base, it will act as a nucleophile. But something like hydroxide, which is a very strong base, or this one, or an alkoxide, these are all going to react as bases before they react as nucleophiles. So in the future, what we're going to do is learn different techniques to have an alcohol act as an electrophile, but not in a strongly acidic environment, so this does not take place.